All right, here we go. Number 5, 2017, AB, calculator inactive. Two particles are moving along the x-axis. They have horizontal movement is basically what they're saying. For 0 to 8, t values, time, whatever time is measured in, the position of the particle p at time t is given by this function. This is the position. The velocity of q is given by this. Position, velocity, okay? Good to know. Hold that in your head as we go. It's going to be important that we keep the position of p and the velocity of q separate. Particle q is at the position x equals 5 at t equals 0. So its initial position is at 5. It starts at 5. That'll come in handy later. Part A, I should say. From 0 to 8, when is particle p moving to the left? Okay, when is a particle moving to the left? When its velocity is negative. So we're going to find the derivative of this position, set it equal to 0, go from there. All right, here goes. Number 5, part A, and they gave us this that you don't have to write again, but I'm going to write it just as a reference. Natural log of t squared minus 2t plus 10. Okay, we need the derivative of this because they want to know when this particle is moving to the left. So we'll take the derivative of that. And I'm going to define that as the velocity of particle p. Okay, so here's what you don't do. Don't start and say, oh, velocity is, and then take the derivative. You need to define the velocity as the derivative of that so that they know. Okay, this is going to involve the chain rule. Not going to write all the steps. The derivative of natural log is 1 over whatever you had. And then we'll multiply by the derivative of whatever you had, which would be 2t minus 2. 2t minus 2. Nothing reduces. The denominator does not factor. Good luck trying that one. Won't work for you unless you start dabbling with some complex numbers and craziness. So let's not. I want to set this equal to 0 and solve it. So first best guess is to set the numerator equal to 0. So that's going to give me t equals 1. Second best guess is to take the denominator and set the denominator equal to 0 and find where the derivative, velocity, would not exist. That would be like an abrupt stop and then it would turn around potentially. I'll go ahead and tell you that this will never equal 0. It's just not going to happen. How do you know? I know. I've graphed these kinds of things. I also know in a very obscure way that it's not going to ever cross the x-axis if you graphed this denominator. And here's how I know. And you don't have to write all this. This is, don't count this towards the 15 minutes, right? Look familiar, I'm sure. If you were going to solve this quadratic with the quadratic formula in an effort to set it equal to 0 and find where your derivative doesn't exist, then you would eventually have, well, 2 plus or minus square root of negative 2 squared, so 4 minus 4 times 1 times 10, all divided by 2 times 1. So you keep working on that. You're going to end up with a negative under the square root right here. So you're going to have 2 plus or minus the square root of negative 36. That would be 6i. You're playing with imaginary numbers. We don't do that in this class, but that also really means that in a practical sense, this denominator will never equal 0. So we don't have to worry about that, okay? Didn't have to go through all that. This is sufficient. You can just kind of tinker with it in your head and move on, for real. So t equals 1. And what that means is we're going to find out where the particle is moving to the left and moving to the right based on a number line. Normally I'd go negative infinity to infinity, but we're going 0 to 8. And to be more specific, we're going 0 to 8 with critical point, potential critical point at 1. So our derivative equals 0 at 1. So I want to know what happens here and what happens here. So we're going to plug in values into the derivative. It's got to be the full derivative. So it's going to be a little easier than you think. I'm switching colors. I don't even know why. So the velocity at some number between 0 and 1, the obvious choice is 1/2. Velocity of p, let's be specific, is going to be 2 times 1/2 minus 2 over 1/2 squared minus 2 times 1/2 plus 10. And that's going to give me a negative 1 in the numerator and positive down here. And really, I'm not going to play too much with the exact numbers. I just care about signs. So that's negative. Here's what that tells me. My velocity is negative between 0 and 1. That answers my question. Now, I also want to confirm that it's not happening here as well. So we'll pick another number in a minute. But I do know that my velocity of particle p is negative in this interval. Okay, so that will be at least part of the answer. Here's the rest of it. The velocity of particle P, pick a number here. 2 is obvious. We'll do that. So 2 times 2 minus 2 over 2 squared minus 2 times 2 plus 10. That's going to give me a positive in the denominator, positive 10 in case you really care. Random parenthesis there, doesn't belong there. Now it fits. Positive and positive is going to give me a positive. So the velocity of particle P is positive here, which tells me fully the answer to my question, switching back to black, and the particle is moving to the left on the interval. You don't have to word it like this. From 0 to 1. And the answer key, which I'm not looking at the moment, but the answer key might have it written as like 0, less than t, less than 1. And they may say equal. Not a huge deal if you make it equal or not. Okay, yeah, here we go. Here we go. So they did make it equal at 0. I think I will do that. I think I'll make it equal at 0 because it does include 0, not necessarily at 1. I really don't think they would count off for that. We'll get back into that in a moment. There we go. So if you're like, oh, bracket, parenthesis, what do I do? I really don't think they make a big deal out of those kinds of issues in these kinds of problems. Okay, part B. Let's stop looking at the answer key and start looking at part B. 4, 0 to 8, find all times t during which the two particles, both of them, travel in the same direction. So here's the beautiful thing. We already know the direction at which particle P is traveling. We know it's going to the left here and to the right here. So now we have to do the same thing for particle Q. And particle Q has this velocity right here. Velocity of Q as a function of time is t squared minus 8t plus 15. And we're going to set that equal to 0 and we're going to solve it. So t minus 3, t minus 5 equals 0. So t equals 3 and 5. We're going to do the same thing, same number line deal. 0 to 8, 3, 5. I'm going to do some stuff in my head here, and I think it's going to be really reasonable. Switching to blue, though. Don't have to narrate what color I'm going to use, but whatever. It slows me down. If I plugged in a 1, 1 minus 3, 1 minus 5, negative times negative is going to give me a positive, so the velocity of Q is positive here. So okay, I'm going to pause right here, and we're going to talk about what's happening. They want to know when the particles are moving in the same direction. I'm going to compare this number line to this number line in a minute. And I'm going to say, okay, when are they both positive? When are they both negative? That's going to help me out. Okay, plug in a 4, 4 minus 3, 4 minus 5, so positive, negative is going to give me a negative. Velocity of Q here is negative. Plug in a number between 5 and 8, it's going to give you positive, positive. So velocity of Q here is positive. Okay, let's go ahead and start our sentence. The particles are moving in the same direction for, all right, we're going to list an interval or two. All right, so we start by going to the left here from 0 to 1 for particle P, and we don't have any left motion from 0 to 1, so no match yet. And then we go to the right from 1 to 8. So I'm going to just kind of look at this and say from the right, 1 to 8. So from 1 to 8, where is this going to the right also? Well, that'd be from 1 to 3. So 1 to 3. And nope, that's to the left. And this is going to go that way as well. There we go. So it's going to be those two intervals right there. Glancing at the answer key, they did this whole bracket thing. Again, I don't think that's going to be a huge issue in the grading, but I want to be consistent with what they put. All right, let's move on to part C. This is an easy one. Find the acceleration of particle Q. Keep them straight. There's your Q velocity. At time t equals 2. Is the speed of particle Q increasing, decreasing, or neither? At time t equals 2. Explain your reasoning. Okay, well, let's do this. I'm going to explain our reasoning. Part C. Find the acceleration of particle Q. So I'm going to write something that you don't have to write again. It would slow you down if you did. 8t plus 15. I'm not going to set that equal to 0. What I am going to do is take the derivative of the velocity, which is the acceleration. Again, don't just say acceleration equals, no, acceleration is the derivative of velocity. We need to define that for the people that grade our paper so we'll know. So 2t minus 8. And they asked something specific, the acceleration of the particle at time t equals 2. So now we're going to find the acceleration at 2. So we'll have 2 times 2 minus 8. It's going to give me negative 4. I don't care that it's negative 4. Well, I do care that it's negative 4 because they asked. But they are also asking for speed. Is it increasing or decreasing? And that is an issue of signs. And so we are going to look at this and say, oh, well, that's negative 4. I care that it's negative. I also need to know the sign of the velocity at 2. Lucky us. We know it. It's positive. So it said explain your reasoning. Here goes. The particle. I'm going to be really specific. Let's say particle Q. I didn't do that on the last one. Oh, the last one said the particles. Okay. Particle Q is, okay, speeding up or slowing down. I'm going to write some stuff over on the side. A sub Q of 2 is negative, and velocity at 2 is positive. Because these signs are different, particle Q is slowing down. So the speed is decreasing. I'm going to get really specific with my language here. This is sufficient, but I'm going to say speed is decreasing because I'm trying to answer it in the way they asked it. Don't beat yourself up over that. I really don't see them counting off because you said slowing down, because that means speed is decreasing. I'm just trying to be really specific with my language because I'm trying to set a good example. Particle Q is slowing down, speed is decreasing because velocity and acceleration have opposite signs at t equals 2. Okay, last part, part D. This is the fun one. Find the position of particle Q. Pause right there. What do they give you? They give you velocity. So the integral of velocity will tell you displacement. All right, we need to know the integral of, I hope I said that, I might have said derivative. We need to know the integral of the velocity to give me displacement. When I replay it in my head, it sounded differently. Integral of velocity will give me the displacement. So let's find the integral of my velocity. Now, this is an incomplete thought. We're going to work on this. And I'll get my displacement, but I need to add my starting position. Okay, so what I'm going to do is find out where to start. 0 is a good place because they tell me that. And I'm also going to find out where to end. Find the position of particle Q the first time it changes direction. Here goes. First time it changes direction, time is 3. T equals 3. So we're going to plug a 3 up here. And this tells me its displacement from 0 to 3. And this tells me where it started. So where it started plus its change is going to tell me where it is. So let's keep going. Antiderivative of this guy is going to be 1/3 t cubed minus 4t squared plus 15t. That takes care of this portion. We're going from 0 to 3, and then we're going to add 5 to that. Let's keep moving. Plug in the 3, plug in the 0, but that changes nothing, so let's not plug in the 0. 1/3 times 3 cubed minus 4 times 3 squared plus 15 times 3. Plug in the zeros, like I said, that's useless, plus 5. All right, 1/3 times 3 cubed, that's going to actually end up being 3 squared. Minus, let's see, that is going to give me 9 times 4, so 36, plus 45, plus another 5, and that is 23. All right, let's grade this thing. Let's see how we did. Pretty well, because I was glancing at the answer key. I already had it worked out, but I wanted to make sure that I worded things or had the intervals exactly as they did, although, again, don't think that's going to be a huge deal. Here goes. Did I earn both points? Let's see. I'd get a point for finding the derivative of the position, which is this, which they factored even further. Either one is sufficient. We did that. We're good. And we determined that. You don't have to write it, but we determined that. And then the interval. The interval is from 0 to 1, which we did as well. So we took a little work, but we got it from 0 to 1. So again, bracket, parenthesis, don't think they make a big deal out of that. We earned both points. Okay, part B, we get a point for the intervals, which were from 1 to 3 and 5 to 8, which we did, 1 to 3, 5 to 8. And we get a point for the analysis using the velocity of particle P and the velocity of particle Q, and the analysis of that would be these number lines. We call it sign analysis. So these things, which are showing up in part A and part B, are going to give us some credit. Okay. Let's see. I'm rereading it. No, we're good. We're good. Okay. Part C. We get a point for the correct derivative of velocity, which is a sub q of 2, and plugging in the 2, which gives us -4. That was an easy point right there. Easy point earned. And then the speed is decreasing with the reason the speed is decreasing, and the reason is they have opposite signs, which is what the answer key says. All right, last one. We need an antiderivative for 1 point. Got your antiderivative right here, and it is correct. We used the initial condition, which was 5, and we had our final answer, which was 23. So we earned all 9 points. There you go.